Hi, everyone. My name is Savannah, and I am a grad student at Auburn University. Today, I'm going to discuss with you all some applications of paleolimnology to urban systems and specifically compare the records of two urban lakes in Florida, USA. You all probably know that urbanization alters ecosystem function in unique and lasting ways, and that's demonstrated in models, natural experiments, and monitoring data. However, urbanization has been a pretty modern and rapid phenomenon, and so contextualizing this urban-driven environmental change is important. Monitoring records like this one in the top right that shows phosphorus shifts capture high-resolution data from the last few decades, which is valuable, but paleolimnological data helps place these records in context, in a historically rich context. And so, in that sense, paleo records serve as really great supplements to monitoring data that help reveal the timing and magnitude and drivers of these urbanization impacts. And so here, the data set that I'll talk to you about today, I'll be comparing nutrient, heavy metal, and photosynthetic pigment records of two urban lakes to really get a full picture of biogeochemical change in these systems. The two lakes that I'll be discussing are in Polk County, Florida, USA, which is a great backdrop for studying urban lakes because it's fast growing, densely populated, and has a high density of urban lakes. Additionally, Polk County's geology is naturally rich in phosphorus and its climate is subtropical. And so those are conditions that can potentially compound some of these pressures of urbanization. The two lakes I have cores from are Lakes Parker and Howard. Both of these lakes are pretty similar in terms of size. Both of their watersheds are pretty much 100% urban, and they're in neighboring Polk County cities, Lakeland and Winter Haven, respectively. Beyond those specs, the lakes start to differ in terms of suburban land use and management. So, Lake Parker has a very rich industrial history. On its shores is a retired phosphate mine. There's two coal-fired power plants on its shore, as well as a wastewater treatment facility. But beyond that, um, no real management has happened in the watershed of Lake Parker. Lake Howard, on the other hand, watershed is almost 100% residential, and it's undergone a variety of both soft and hard path management approaches. And so there's been wetland restorations, and there's been street sweeping implemented, and there has also been the lake has received continuous alum treatment since 1999. So, like I said, we, for both of these lakes, measured nutrients, heavy metals, and pigments. And so I threw variables from each of those categories into three PCAs. Here we have the heavy metal data from both lakes. Lake Parker is in red and Lake Howard is in blue. And what we see is that along PC1, all of the variables are oriented positively. We see this same orientation pattern with nutrients. Again, really straightforward pattern along the x-axis, low nutrients to high nutrients moving from negative to positive. And we see the same thing of pigments. So collectively, we can capture these x-axis values and use them to represent total metals, total nutrients, and total primary producer abundance. The other thing to point out about these PCAs are the two ellipses on each figure. The gray ellipses include 95% confidence interval data for dates prior to canal construction in these systems, and the black ellipses include data following canal construction in both of these lakes. So we see across the three variable categories that pre-canal data is significantly lower in metals, nutrients to an extent, and pigments, and much less variable. The last thing that I'll point out in these figures is the y-axis in the pigments PCA or PC2. Below zero, we have pigments representative of diatoms, chrysophytes, and some cyanobacteria. So a sort of diverse algae community structure. And above zero, we have a 100% cyanobacterially dominant community structure. So here are the PC1s now displayed as typical paleo profiles. And again, in both lakes, I see this big shift right before 1920 across metals, nutrients, and primary productivity. And that happens to mark the period pre and post canal. And so canal construction really seems to trigger, like we saw in the PCAs, increases in heavy metals, nutrients, and primary productivity in both lakes. Following this increase, or following canal construction, this increase tracks pretty well with population growth in both cities. And then across these variable categories, we see some 90s era petering off, likely due to national regulations like Clean Water and Clean Air Act. Granted, there are certainly some fine scale differences here between the two lakes, but overall, biogeochemical patterns of these two lakes across variables are remarkably similar in terms of timing of shifts. But when we're thinking about urban systems, which are these heavily used and heavily managed systems, what I'm really thinking about here is the bottom line. And what I mean by that is the biotic response. And so let's revisit that pigment PCA PC2 axis, which gives us information about algal community structure. And if you remember that values below zero for PC2 indicated a pretty robust and diverse community structure, whereas values above zeros indicated complete cyanobacterial dominance. And so let's see when the periods above zero are in these lakes. So that's interesting. It turns out that cyanobacterial dominance is one, a modern phenomenon beginning really only in the 2000s. It's a persistent phenomenon, unlike a lot of these other variables, which have these big trends but kind of vary from year to year. Here we see um, a persistent shift towards cyanobacterial dominance once it occurs. And three, that's a pattern. Both the timing and persistence of cyanobacterial dominance is conserved across these two unconnected lakes. And so the big takeaways here are that stochastic dynamic events like canal construction are responsible for big inputs and big initial changes in these systems. Also, that sort of land use wise, urban is urban and really is more reflective of the region as a whole, and whereas the consequences of land use and the consequences of lake management are secondary in these systems. And also, finally, that a couple decades of nutrient loading triggers modern cyanobacterial dominance. And from what we can see in this paleo record, those shifts are persistent and there's certain, decades worth of human activity becomes really difficult to manage your way out of. So I know that I'm recording this talk, but if you have any questions, my email is slw0093 at auburn.edu. And thanks.